Okay, in this video I will show you how to find y of x to see if that in this is a quadratic function, and we are going to try to put this in terms of our maximum range, the height, and the time of flight. In the previous videos I derived these equations. And we are going to try to put the y of x as in terms of r, so to see that this is at r over 2 and y is equal to h. Alright, we have this equation. And the origin is 0, and if this is the velocity, the initial velocity, and this is the angle, you know that this piece over here is b naught x, is adjacent to the angle, so what fraction of b naught is just multiplied by cosine, and the y component is b naught sine of the angle. So the equations become and now we 1 and 2 find t in 2, so t is x over b naught cosine of the angle, and substitute it in 1, so we get y equals b naught sine of the angle times x over b naught cosine of the angle whole square. Now the b naught cancel and sine over cosine is tangent. Again, this is y of x times x minus g over 2 b naught squared cosine squared of theta times x squared. As you can see, it's quadratic in x expected. And now we want to find the derivative, because we know that the maximum happen at half the range. Let's see if that's the case. And the maximum is h, this value over here. So let's find the derivative with respect to x. So this is tangent of theta minus g. The 2 when goes to the front, cancel these 2, times x. And if you set the derivative to 0, x is tangent of theta times b naught squared cosine squared g. But tangent is sine over cosine, so 1 cosine cancel, and we get b naught squared over g sine of theta cosine of theta. We multiply by 2 and divide by 2. This is sine of 2 theta, and indeed the maximum happened at this value, which is this is r, which is happens as expected as half the range. Okay, just check that. Now y at half the range is supposed to be the maximum height. Okay, and I don't know if it's easier to modify this equation because you got b naught cosine squared, and over here I have tangent. Let's see. I think it's better if you try to make this equation dimensionless. Spouse the. Okay, so let's substitute r over 2 in here. So we got tangent times r over 2 minus g to b naught squared cosine squared times r over 2 squared. And that's supposed to simplify to h to b naught sine squared over 2g. Okay, so let's do it. So you have tangent is sine over cosine, and r, and now I'm not going to put sine of twice the angle because I know I'm supposed to get just sine the angle, so I'm going to start putting this is b naught square over g 2 sine cosine. So this is the one that I'm going to be using. And if I divide by 2, these two cancel, and I get b naught square over g sine cosine minus g to b naught square cosine square. The same thing, b naught square over g sine cosine square. So I need to go to another paper to have it more simplified. So y r over 2 is supposed to be h. That's what I'm showing over here. So y r over 2 is sine over cosine sine times cosine minus g to b naught squared square. Right, this cancel here. Get b naught over g sine square, and this cosine cancel this cosine, this g cancel 1g, have these two, g and g squared is g, b naught to the fourth and b naught cancel, so get b naught square, and the only thing left over here is sine square. And yes, 1 minus a half is 1/2. So y r over 2 is b naught 2g sine squared. Okay? And this is y, the maximum. On the previous video, I showed you that this is the maximum height. So y r over 2 equals to h. Now, I think it would be nice to put everything in terms of r and h, because this is a trajectory in a space. You don't necessarily need to have information about time. So r is the range equation. And this is the equation we have, tangent of theta x minus g over 2 b naught squared cosine squared theta times x squared. So I don't want these terms in terms of the angle and the initial velocity. I want it in terms of r and h. So the first thing to realize is that r h over r, you divide these two, and again, anytime you see sine of 2 theta, you are going to put 2 sine cosine. Okay, so is b naught square over g 2 sine cosine. So one sine cancel, this cancel, this cancel, this cancel, this cancel, and the 2 doesn't cancel. Yes, the 2 cancel as well. So sine over cosine is tangent of theta. 1/2 over 2. The half cancel 2. No, it doesn't cancel, you get 1/4. So the 2 doesn't cancel, you get 1/4 over 4. So tangent of theta is 4HR. So this over here is 4h over r. Now we'll do the same. Since this is x squared, this has to have units of 1 over meter. So we do h over r squared. So b naught squared over 2g sine squared over r. It's going to be b naught to the 4th over g squared, then 4 sine squared cosine squared. And that's the reason I did it. You see the sine cancel. And I get this cancel too. And this is not g to the 4th, this is g squared. This is g. This cancel this. So it's 1/8 g. This g goes top. B naught squared cosine squared over g. So you can see now that I can break this like 4 and 2. So this term over here is 4h r squared. So this over here is 4h r squared. So my y of x is 4h over r times x. This is dimensionless because this is in meters, minus 4h over r squared x squared, and this has dimension of meters. I can take 4h 4h, I think this is the best way to put it, times x over r. So this is dimensionless, and this has units of h, and then this is 4h x over r squared. Now if you take the derivative, is 4h over r minus 8h over r squared x. Set that to 0. Over r. The h cancel, 1r cancel, 1, 2, and x is r over 2. As expected. As expected. Now we substitute this over here. We are supposed to get h. So y at r over 2 is 4h. So x over r, you get 1/2 minus 4h 1/2 squared, which is 2h minus h, right? 1/2 squared is 1/4 and 4th cancel out, and you get h. So y at r over 2 is h. So this is the equation. That has everything. I think the best way to put it is 4h x over r. I think that takes x over r common factor. So y of x is 4h x over r minus x over r square. No. I'll put a cleaner way over. Y of x is 4h x over r 1 minus the 4h is x over r, like this. Okay, and this is the equation of the parabola for the projectiles in terms of h and r. Because remember, this is the physical displacement of the object, and what is the time here? Because time is hidden in h and r. Remember, h is v naught squared over 2g. You see, velocity in meters per second, g is in meters per second squared. That's where the time is. And r is and that's where the equations are. So in summary, this is the parametric parabola. It's 1L. This is the Cartesian parabola. this is the Cartesian parabola in terms of the dimensions that are in length h x over r 1 minus x over r. Remember, this is r0, this is r over 2h, and very important, this is 0, 0. So this is the, if you have the calculator, you can plot it in, nowadays you can plot this in parametric right away. So this is it for the video. So you have to see it this way. If you have initial velocity, angle, and g, you can put them in terms of r, h, and tau. So you got 3 parameters. Here you have 3 parameters. So everything is consistent in one way.